So the question number 1 is, wow, this is way off today. NH4, NO3, guys, here's what I want you to do. This reaction is unbalanced. I want you to please balance it real quick. Okay. This reaction is not balanced. I want you to balance it real quick. Okay, so we have ammonium nitrate plus sodium phosphate yields ammonium phosphate plus sodium nitrate. Now this should be fairly simple to balance. Did I mess something up? Yeah, that's right. Okay. So 31, 13. Okay? So that's what it should be. 31, 13 is what you should have. And then it tells you, answer the questions above, assuming that we started with 30 grams of ammonium nitrate. So I've got 30 grams, excuse me, it just says 30. So we're just going to put a decimal to make it 2 sig figs. 30 grams of ammonium nitrate and 50 grams of sodium phosphate. So I've got 50 grams of this stuff. Okay, now, question A. Which of the reagents is the limiting reagent? B, which is the maximum amount of each product we can form, and then C, how much of the other reactant is left over. So we want to make sure we cover all of these, and then finally D, you can't even do, so scratch D off. We can't even do that. Okay. It'll be A. Here's the balance equation. A, what's the limiting reactant, or B, how much of this is produced. Yeah, okay. All right, so here's the deal. Now, part C, it says how much of the other, part B, what is the maximum amount of each product that can be formed? We're not going to do each product. We're just going to pick this one. And I'm going to go to moles just to make it nice and simple in the first one. Okay? I'm going to go to moles in the first one. So, but which one of these two reactants do I pick? Do I take 30 because it's the least? Got to find the what first? The limiting reactant. Now, again, since we're converting, and I know what all of you are thinking, ooh, I'm going to use that cheap thing. LR equals moles divided by coefficient. Now, this is only to be used when and when only. When it point blank says, what is the LR? Now, in A it does say that, but however, doesn't in part B it wants you to convert to something? So let's just go ahead and do it how we always do it. It's the same exact step. Did y'all see that yesterday in the video where I showed how it's the exact same step? Okay, it shouldn't make any difference. It's the exact same thing, it just looks a little different. Alright, so I was real generous in this worksheet. Why? I gave you the masses. How nice of that. Thanks, Mr. Richards. Shoot, no. Looks like you're going to be shooting with an F. For real, you got no masses? No. Why? Honestly, I hadn't even made a chip. In the past, I have done a comprehensive. This year, I don't think I'm going to be able to get to because of all the time that I've missed it recently. Because I'm needed too much across the entire spectrum of everything I do. You have no idea how bad I wish it was easier than said than done. Now, no, not now. I've got that 10-year plan. It was never mind. Listen, who was it was talking about the other day? In 10 years? Yeah. It's all right, so I've got all this set up. Can you at least pull? Yes, ma'am. I will specify for sure. And this one, in part B, it says what is the maximum amount of each product. And this worksheet wants you to do it for both of them. I just pick one of them, but on the test I say how many of this particular one. You convert the known masses to the unknown. You with me? Alright, so Do you have all the data that you need to plug numbers into this? Okay. Which one of these is the easy one to do? Well, normally, which one's the easy one to do? The mole to mole, right? Because it comes right from the coefficients. You don't have to do any calculations. What is the mole to mole from top to bottom in the brown color? Very good. It's 3 over 3. And what is the mole to mole on the bottom one, or the green one, top to bottom? Okay, it is 3 over 1. Now, I do give you the masses in this, and ammonium nitrate is 80.04, and sodium phosphate is 163.94. Has anybody done these numbers yet? Okay, 1.1. Very good. 1.1 moles of NaNO3, and what's the bottom one? 0.91 moles of NaNO3. All right. What was the original question? Okay. How many moles of what can I form? NaNO3. All right. What's wrong? I'm not thinking. I'm just going on what you said. What is it? Well, that would have messed the whole answer up. Great job, Cassie. I'm just kidding. I'm just messing with you. What? Because I don't. Okay. So, based on this now, which one is our LR and how do I know? Okay. This right here. This is my LR, and how do I know? This is the easiest way to say it. It produced the least. Does that make sense? It produced the least. You can only make as much as your least amount produced. Yay? Okay. Have I answered the actual question? Very, very far, it says question mark moles. Have I answered that question? Do I have moles of NaNO3? I sure do. Which one is my answer? There's my answer right there. Now, this one's a little bit simpler because it didn't ask for what unit. Grams. How could you take this and how could you answer it if it were grams? You would multiply that by the molar mass, and the molar mass is 85, right? Yes, ma'am. Convert it to moles and stop. Okay. But now, if the question were how many grams of sodium nitrate were formed, you would just take the top one and convert it over. Does it make sense? You wouldn't have to worry about the bottom one anymore. All right, everybody good on that? Yay, nay, maybe? Yay. All right. Now, I'm telling you, make sure you know how to do this. Part C. How much of the excess reactant is left over after the reaction is complete? All right, so here's the deal. Limiting reactant, after the reaction has ran, how much is it going to have? It runs out first. So of that 30 grams, how much are you going to have at the end? None of it. Of the 50 is what we're trying to find out how much is left. So you may kind of want to jot these down. These are the steps to I was writing like this. Excess remaining, and it's only 2 steps. Okay? What's wrong? Step 1. Convert LR to ER. And there's a little factoid that you need to know. This gives you used. Wow, used doesn't start with an S. Okay. Does anybody remember step number 2? Very good. It started with minus used is equal to the remaining. Now there's one key part about this that I don't harp on it enough as I should. The units must So if the starting, what was the starting unit given out? Grams. So what does the used have to be found in? Grams. You see what I'm saying there? You can't subtract moles from grams. It doesn't make any sense. So make sure that your units match. All right, so let's do, let me just pause it and let y'all write that down. Okay? All right, so let's convert LR to ER. So we started with 30 grams of NH4 NO3, right? And then we go to grams of NH4 NO3 to moles of NH4 NO3. That's wrong, friends. Yep, this is C. I know. I hate these big long compounds. The ones I use aren't ever this long. Those polyatomics make it learn tiring. Okay, now the good news is, like I said, I gave you the mass for these. So I've got 80.04 in 1 mole. And over here I've got 1 mole in 163.94 grams. Now, what is your mole to mole in this one? 1 over 3 or 3 over 1? 1 over 3. Okay. What's wrong? So in your calculator, this is what I would do. I would do 30 times 163.94 divided by parenthesis 80.04, times 3, close parenthesis, and then hit equals. That's what I would do in my calculator. And that's going to give you the answer right then. You don't have to do any changing or any equaling. It just, you plug it in and it gives you the answer. So what is it to 2 sig figs? Okay, so 20 grams of Na3PO4. Is that my final answer? No, this is what was what? This is your used. And it scares me every year that students do this and they stop. Oh, that's not right. Okay, so now, one easy subtraction. So started with minus used equals remaining. How much did you start with? 50 grams. We used 20 grams, which obviously leaves us how much left? 30 grams. 30 grams of Na3PO4 remaining. Everybody a little more confident with that? Yay, nay, may? I like that. Yay, nay, may? Yay, nay, may? Ha, 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 ha. Yay. Okay. You ready? You want to do the other one? Huh? No. So first thing we got to do is balance it. So I need a 3 here and a 2 there. All right, and then it says, answer the questions at the top of the sheet, blah, blah, blah. So we start with 100 grams of calcium carbonate. So I've got 100 grams of this. And then we've got 45 grams of iron 2 phosphate. All right, now, and normally I'm going to say pick one. You guys tell me, which one do you want to go to? I don't care. All right, we'll go with iron. So that's the first one I heard. So we're going to go this time. We're just going to go to grams, just so you can see a gram-to-gram conversion. The problem is, I don't know which one of these I don't know which one I need to pick. Do I pick 45 because it's the least? No, thank you. All right, so let's run through this real quick. So I have 40. You know what's going to make it simpler? Let's leave the compounds out just for fun. Okay? All right, so 45 grams of this. We're going to moles of that. And then we're going from moles to moles. Now, here's the problem. Be honest. If you wrote that and you didn't write compounds and you came back to look at that later, would you have any clue where any of that came from? And that's the problem. Every year, students do this. They're like, I don't know where any of these numbers come from and go. You don't know what you're going from and you're going to. While you're doing it, you do, but once you go back and look at it later, you don't. Now, again, the great news is I gave you the mass of these things. So it's 100.09 on bottom. Now, what is my mole to mole from calcium carbonate to iron to cobalt? Okay, it is a 1/3. Okay, now somebody run those numbers while I write the bottom one. 100 grams. So I'm going gram to mole, and then I'm going mole to mole. Yeah, that's exactly what it is. 0.33. I wasn't paying any attention to it. And that is moles of Fe2CO3. Did I do that wrong? Got those backwards. All right. Yep. See, that's why you write stuff down. I got the numbers wrong. It's 100 grams on top. That makes it 0.33. See? Prime example of why we write stuff down. Way less confusing when I write them or don't write them. All right, so just follow the colors. This came from here to here. That mole to mole came from 3 to 1, right? The green, this one came from the 2 to the 1. The masses are already on there, right? You with me on that? Okay. All right, so what's the bottom one? 0.15. 0.15 moles of Fe2CO3 2. Did that earlier today. All right, from this, can you determine your LR? Who is it? Very good. Why is this the LR? It produced the least amount. All right, have I answered my question though? Have I? The question is how many grams? What's wrong? Why are they saying what? Because we went from both of these, like this and this, to that. We're finding the LR. So you can only stop here is if the question said how many moles of that's produced. But the question wasn't moles. Yeah, this is B. Excess. Okay, so we still got to finish B. We're still not finished with B. All right. So 0. I'll come back. I promise. All right. So let's go back. Let's look, because I need to go in 2 minutes. Hang on. Shh, Abby, ask your question. All right. Do you know why we did 2 steps? Okay, I'll go back and fix it. All right. So we did 2 steps to find the limiting reactant, right? I converted the known to the unknown, and I found that my limiting reactant had to be iron 3-phosphate because it produced the least amount. The reason I can't stop here like I did in the last question said how many moles of product are produced. Well, that's moles. We can stop. But this question says how many grams of product are produced. So you take the least amount and go one more step. You with me? So now I messed this up. Don't write this down yet. I've inverted these by accident. I've got to go from moles on bottom to grams on top, which is 1 mole is in 291.73. How much? 44 grams. Okay, so we got 44 grams of Fe2CO3 2. That's how much will be produced. Hey, I did it again. CO3 3. And then how much excess? Now this has nothing to do with excess. Oh, that was what the question was. So if I go back and look in the top right hand corner. The question said how many grams of iron 3 cobalt are carbonate are produced. That's why we went to grams of that. Okay. Last part. Now I've got to find out how much excess remains. So of my 45 grams, that's my limiting reactant, how much of it will be left? What happens to your limiting reactant? It runs out. It'll be zero. It'll be depleted, right? Well, I have some of that 100 left over. Yes, so I've got to figure out how much of it's left over. So how do I solve for how much remains? Convert LR to ER. That's used, and then subtracted from what you started with. Okay? No. We're going to grams of the excess reactant. What was my mole to mole ratio top to bottom of this one? No. 3 to 2. 100% positive. See how ugly it looks when there's no formulas? That better? Two. This is converting because this right here, the FePO4, Callie, can you see? This is my LR. Okay. This right here is my ER. Okay. Now, when I calculate this, this is going to give me my amount that is used. What is that number? 45. Alright, so 45 grams. So how much did I start with? Started with 100 grams. Okay. I used how much? 45, and so that tells me how much is remaining. 55 grams remaining. Yes, percent yield is really easy though. You take the actual and divide it into the number that you get on stoichiometry. Yes, no. Because it's the other reactant. Alright, look, right here. The way you know it's the ER is when we did this, the ER is the one that produced the most. Alright, if y'all will flip over real quick. Hang on one second. Last part. Mary, this is going to answer your question. Number 5 on the other side, it says if 11.33 grams of sodium chloride are formed in the reaction described, what is the percent yield? All right, so remember what does percent yield stand for? Okay, actual over theoretical. Okay, or what you said is what you got divided by what you wanted. Now, they tell you how much did you get. 11.3. Now, the way you're going to find out how much you wanted was in number 2. So it's the answer you get in step number 2 on this part, okay? You'll actually have to solve for it. I don't know what that number is. That would be the theoretical. It says how much sodium chloride can be formed in step number 2. That's the number, whatever that answer is. Yeah, it is. It's just separating it out. Which is kind of how y'all's test is going to be. So separating it out. 5. Okay. All right. Go ahead. Yes.